लेकिन उसी के साथ जो मुख्य कार्यक्रम है, आप सभी को सम्मानित करते हुए तथा आज के इस कार्यक्रम की शुरुआत करते हुए मैं प्राज इंडस्ट्री के सुभाष चंद्र सर से रिक्वेस्ट करूंगा कि वो प्लीज़ डायस पे आएँ और यहाँ पे वो अपना प्रेजेंटेशन दें। कई सारे लोगों को थोड़ी सी बैठने के लिए जगह नहीं मिल रही है, बीच में जी कई सारी कुर्सियाँ खाली हैं। कई सारे लोगों से रिक्वेस्ट है कुर्सियाँ पकड़ के ना बैठे, क्योंकि ये मामला पूरा कुर्सियों का ही है ना, तो प्लीज कुर्सी पकड़ के ना बैठे। थैंक यू। इसके बाद वन ऑफ द बेस्ट हैंडसम पर्सनैलिटी यहाँ पे आ चुकी है, सुभाष चंद्र सर। एक बार जोरदार तालियां सर के लिए। सब प्लीज
जहां की शान है, हम सबका है अभिमान, इस धरती को दे खुशहाल।
Good morning everyone. I thank Bharatiya Sugar for giving this opportunity to present here. I am from Praj Industries Limited, Pune. I'll be presenting on ethanol, the green revolution. So this is the latest second generation plant recently inaugurated by Honorable Prime Minister Mr. Modi. So I'll be talking about very little bit on updates on Praj. Most of us already know about Praj. Drivers for sugar and sugar streams to ethanol, and round the year operation technology, advanced technologies in first generation ethanol, also on future fuels which is beyond sugar and ethanol. So this is about Praj. We are almost more than 38 years old company based in Pune, and we are references more than 100 countries, and we have more than 1,000 references to our name. We have 4 manufacturing facilities. We have 1,200 employees, out of which 90 are PhD, and we have 300 patents to our name in different countries. Almost 10% of the global ethanol production comes from your own Pune-based technology company. So this is our competency. We are into technology, innovation, engineering, integration, and manufacturing and commercialization and scale-up for ethanol plants. This is the latest updates on Praj. So we have awarded first best place to work, and we are in the 50 hottest companies in bioeconomy, also 50 hottest projects in advanced bioeconomy. So this is our chairman, Mr. Dr. Chaudhary, got this prestigious award for his achievement in biotechnology space. He's also got a lifetime achievement for his excellence in biotechnology space. He's the first Indian to receive this award and second Asian to receive this award. So what we are doing in Praj just now is beyond ethanol. So if you see, we are talking about bioeconomy. So bioeconomy, if you see, we have 2 platforms. One is bio-mobility platform, which is for transportation fuel. Another is bio-prism, so which is actually into renewable chemicals. So in the bio-mobility space, if you already know that first generation ethanol, which is used as a fuel mixing into the petrol. And beyond that, actually, if you see, there are other fuels, which is like marine biofuel, sustainable aviation fuel, which are actually future fuels. Similarly, for bioprism, the bioprism means you can put one feedstock and there are multiple product coming out. So that's why we named it as a bioprism. So this is standing on number of pillars: social benefit, economic benefit, environmental benefit. A lot of carbon reduction can be done through this. So this facilitates the decarbonization through the bioeconomy. So this is our expertise: feedstock, technology, and product. You name any feedstock, we have a technology for that. For example, cellulosic feedstock, we have a 2G second generation technology, and number of products like ethanol, CBG, lignin, all this we can produce. So we have fingerprinted almost 1,000 feedstock in first generation category and more than 600 feedstock in second generation category. So this is about the bio-mobility. As I said, conventional biofuels, first generation ethanol is already there, commercialized. Many of are using that. And we have already reached 10% blending in India already, and we are going for 20% blending by 2025. So if you see beyond that, there are marine biofuels, which is into next generation fuel, sustainable aviation fuel, and advanced biofuel like second generation. You can produce ethanol from press mud, you can produce ethanol from bagasse as well. So I'll talk about ethanol. These are the drivers. Everybody knows that E20 and beyond, these are some drivers already government has provided us. So this is about making India, reducing carbon footprint, doubling farmers' income, etc. So what we have done as of now is we have reduced almost 26 million barrels of crude import, and we have saved more than 410 million of foreign reserves with this ethanol blending. So this is from our sugar factory. One cane can, everybody knows that cane can produce juice. From juice to first generation ethanol. From juice you can produce syrup, and from syrup again you can produce first generation ethanol. You can also produce first generation ethanol from molasses. And from bagasse you can produce second generation fuel, and press mud you can also produce biogas. So cane is like, our sugar factory is like a kalpavriksha, what we can say. So these are the given requirement in today's date: yield improvement, steam economy, plant efficiencies, etc. So beyond that, actually there are government policies keep coming up, climate change, market dynamics. So the new requirement is feedstock availability, round-the-year operation, minimum ROI, minimum execution time, and flexibility in operation. So there are many challenges: seasonal feedstock, sugar. So we have a number of technology for those. So all know that sugarcane juice is not perishable. We have to immediately process that to produce ethanol. So there are some challenges. You cannot operate this, or you cannot store that. So we have a syrup in the making. Then you can improve the shelf life, but contamination you cannot avoid. Similarly, if you store the syrup, there will be crystallization. So you cannot pump that. So round-the-year operation is still the challenge. Beyond that, when we are using today's date syrup, most of sugar factories are using syrup, but there will be a lot of variation in the bricks. So we cannot control that. So every sugar factory may be having this problem. There will be variation of 5 to 6% variation. So we cannot control that in sugar factory. Whatever syrup comes, ethanol factory has to produce ethanol. So we have come out with some solution. So this is what it is. So we call it as end-leaven skid actually. What it does is, it will take the syrup, and any variation is there, it will, you can fix the bricks by pressing a set point like 50 bricks. So even if 55 bricks sugar syrup comes in, it will dilute automatically. It will measure how much flow is going on, and you don't have to do anything. So you have to set this fermenter, sugar syrup is going, any bricks, you have to give the set point, and it will fix entire fermenter, same bricks. So for the round-the-year operation, solution is bio-syrup. We have to store the syrup, so we have to invert that syrup. Simply, if you store the syrup, there will be crystallization. So avoid crystallization, you have to invert that syrup. So if you see the characteristic, compared to syrup or molasses or B-heavy molasses, bricks is almost same, but if you see the TRS and FS, it is more actually. So how do we do it? Is after your evaporation, it will go to pan evaporation, and then pan concentration, and then it will go to crystallization, and it will produce sugar. Similarly, from your existing pan, we can produce this bio-syrup. We have to invert that in 55 bricks, and we have to concentrate in your existing pan. So this is our journey. We started this long back in 2018, and we have already inaugurated this in 2021 in Jaivan Sugar, Maharashtra. We have tested this. We have stored the syrup for almost 1 year, and we have taken that, and there is no loss in the sugar, etc. So applicability, of course, for off-season production of ethanol, and for, let's say, there will be no cane situation in sugar factory. Most of the time, let's say 8 hours, 10 hours, or maybe one day there is no cane, then instead of shutting off the distillery, you can use this biosyrup. So we have received this Golden Peacock Award for the innovation of this biosyrup product. So now I'll jump to some of the advanced technology in first generation. So this is for steam reduction. We have started with 5.4 kg per liter steam, and we have gone up to steamless distillation. Similarly, in evaporation, we have started with 2.8 kg per liter steam consumption, and we have reached up to 0.3 kg per liter by the help of MVR. This is new technology, mechanical vapor recompression. This requires no steam at all. So similarly, we have a lot of problem in the water consumption. So always there is a very high water consumption. There are many recycle streams, but apart from that, there is also cooling water makeup water requirement is there. So we have this ACHE. So with this, almost 75% water can be reduced. We have number of installation based on that. And similarly, for expansion or reduction of steam, we have a new technology called evaporative distillation, which can increase your 30% capacity of existing plant. Similarly, we have a dehydration plant capacity expansion called Maximol, which can easily increase your capacity by 30% by very, very small add-on equipment. So this is shift. We have always problem in the spent wash. So we need to have a lot of recycle. So we do the recycle, but there will be a lot of acidity problem, etc. So we have something called shift, which actually controls your acidity, etc. while recycling. With this, we can recycle spent wash almost 50%. Now I'll jump to second generation update. So we have started this second generation pilot plant in way back in 2009. And we have started with 1 ton per day plant in our laboratory, and then we have upgraded this to 12 ton per day in Muscova sugar. And now we are building 425 ton, actually 100 KLPD on second generation. So this is recently inaugurated, ready for commissioning in end of September. So this is what we do. This is very similar to your existing 1G, but there is some treatment, pre-treatment is required. So, and enzymatic hydrolysis, etc. Rest of the things you can use your 1G plant. So, if you have 1G plant, this pre-treatment can be bolt on. So, this is update on CBG, that is compressed biogas, which is very, very similar to your existing CNG. So, this is coming from our own sugar factory. From press mud, we can produce the CBG, that is gas. So we have already commissioned this plant in Uttar Pradesh for IPL. So from press mud, we are producing CBG, and that CBG is fed into our vehicles already. So this is the technology for CBG, some pre-treatment and then gas purification. So this is the updates on the government policy. If you see now under Satat, we can sell this CBG for around 54 rupees to 70 rupees. We can also have a number of solid organic manure, which can also fetch some revenue, and liquid manure. So these are some of the plant already commissioned, one in UP and another in Nirani for Karnataka, in Karnataka. So we are talking about biorefinery. We have a crude refinery. We know that, everybody knows that in crude refinery, we get number of products like kerosene, diesel, petrol, low fuel, etc., bitumen, etc. Can we have this similar from our own sugar factory? Yes, possible. We can produce CBG, bioethanol, biochemicals, jet fuels, renewable biodiesel, bio oil, number of even biobitumen or biofertilizer. So we are transiting from crude to bio refinery. So this is just update on biofuel, this ATG. So alcohol to jet. Can we have a sustainable aviation fuel? Yes, we can have. So this is from your own sugar factory. This can come, this existing distillery, we can have this aviation fuel. So intermediate alcohol we normally produce. From there we have to do some catalytic transformation. So we can get the sustainable aviation fuel. So we have a tie-up with a company called Geo for the yeast. There is some special yeast is required. So we have partnership with them. They have experience in producing this SAF already in US. So it is about to ready for commercialization. So we have already signed a MOU with Indian Oil for a number of things like SAF, CBG, 2G, etc. So do we have a feedstock for this SAF in India? Yes, there is a lot of biomass available. We can produce sustainable aviation fuel through this. So this is about the bioprism. I talked about biochemical, which is beyond your CBG and 1G or second generation ethanol. You must have heard there is already the ban on plastic, first use plastic. So this is the alternative. So we can produce plastic from these chemicals from our own sugar factory. So there are some plastic bio-based chemicals like polylactic acid, which can produce bioplastic. So this is about Praj. Thank you very much. If you have any questions, I'll be happy to answer. I hope it is not gone beyond this thing. No questions?
We are talking about sustainable aviation fuel. More of the sugar millers are willing to do this project, but there is a policy which needs to be implemented first, so that we can get an assurance about it for 5 years or 10 years or something as such. Then we can go ahead for the investments as well.
Yes,
if you
correct.
could share some thoughts about it, if you have discussed any about it with government officials also.
Yes, if you see the demand for sustainable aviation fuel is huge, actually. Very, very high. And of course, there is a policy in making. It's about to come. And also, if you see the updates, actually, we have tested this. We have made this sustainable aviation fuel in our R&D center. And we have tested, we are given, in fact, testing this in Air Force with the help of IOC. We already tested. There is a lot of norms, actually, to meet safety, etc., that we are testing. But of course, going forward, there will be policy on that. And a lot of cellulose biomass is available in India, which can produce this biofuel, aviation fuel. Yes, thank you. But it's a future. It will take another 5 years to commercialize. Okay, thank you very much. Thanks very much.